Hello, I am Sheereen. My group consists of Maya, Val, Yew Chong, and I. In this video, we will be exploring our group's engineering solution to bringing fresh produce in a retail setting. The idea our group has come up with is the greenhouse vertical farm. This idea comes from combining vertical farms and greenhouses. The greenhouse allows the control of the temperature and climate to grow produce that normally cannot be grown in Singapore's tropical climate. We will place these farms on the roof of malls and supermarkets to take advantage of Singapore's sunlight. Since Singapore is a small country, we took advantage of vertical space by filling the greenhouse with vertical farms. Lastly, because it is locally grown, we can ensure the quality and freshness of the produce. During the peer evaluation session, we received several questions about the farm's productivity and freshness. To answer these questions, our farms will be installed on supermarket and shopping mall rooftops, and produce will be fresh as the farms are spread out throughout Singapore, which means that the transport time from farm to market will be short. Here is the methodological chart we have come up with. For the final solution set, we chose the Ferris wheel system for the shelves, a pyramid framework, and a temperature regulator. We chose the Ferris wheel system as it allows easy accessibility to the plants. It also eliminates the risk of workers falling when using ladders or elevators. Additionally, the shelves can be rotated to ensure that each plant gets an equal amount of sunlight. However, it is important that the shelves are made of corrosion-resistant materials, as it will come with contact with moisture often. Another con is that it requires complex parts and assembly. For the framework, we chose the pyramid. The pyramid-shaped greenhouse has a flat surface that allows for sunlight to pass through easily as compared to a curved surface. In a flat surface, the light rays do not converge at a fixed point, meaning that the light rays are evenly distributed over the crops instead of a single spot. However, it would be hard to find access to locations where we can place the vertical greenhouse farms on roofs. To take advantage of natural sunlight in Singapore, it is also expensive to build. Lastly, it is expensive to maintain. The last part is a temperature regulator. We chose this as it is designed to automatically adjust the greenhouse vertical farm's climate system to heat or cool the crops to the specific temperature you set. This allows more variety of crops that normally cannot grow in Singapore's tropical climate. I will now pass the time to Maya, who will explain about the materials used in this project.
Here is our concept sketch. Our greenhouse vertical farms to be placed on roofs of buildings near markets so crops can be harvested and then easily transported to be sold. Now we will talk about the considerations for material selection. What kind of properties must our Ferris wheel system shelf have? So, our shelves must be lightweight so that the rotary device can easily rotate the shelves. It must be made out of hard material to ensure the durability and long-lasting nature of the shelves. The material must be stiff so that it can resist deformation in from the heavy load of the dirt, water and crops. It must be corrosion resistant as the greenhouse will be a very moist and humid environment, meaning that the material used for the shelves must not easily corrode, ensuring that the shelves will not be weakened or fail quickly. Now we will be moving on to the properties a greenhouse framework should have. It must be hard to ensure its durability. It must be tough so that the pillars of the structure will be able to withstand the weight of the cover. It must be transparent so light can pass through the cover as crops need sunlight to thrive. It must have low thermal conductivity so it does not affect the internal temperature of the greenhouse, as some produce grows best in certain climates. It must also be corrosion resistant to moisture, rain or humidities of Singapore's climate. We came up with multiple suitable materials to be used for the making for our cover, structure, and Ferris wheel shelf system. Here are the materials. We then use the decision matrix table for the choosing material for our cover, with 1 being the lowest ranking and 5 being the highest ranking. The highest score for our cover would be the polycarbonate, as it is scored 24 or 0.25. I will now talk about why using polycarbonate is suitable for our cover. So polycarbonate ensures that we have protection from UV rays. It is heat resistant, which is good since we need to maintain the inner temperature of the farm. It is lightweight, it is tough, it allows a favorable amount of light to shine through, and is more durable compared to other materials like polyethylene and polyvinyl chloride. However, there are some disadvantages too. For example, it can be subjected to yellowing, which will affect the percentage of light passing through. This can be solved by using UV coating. It also has low abrasion resistance, but this can be solved by adding anti-scratch coating. Condensation can also occur in the farm, which will accelerate the growth of algae, which can also reduce light transmission. The growth of algae on the ceiling can make it hard to clean. However, this can be solved since our farm has a thermostat to regulate the temperature and humidity, ensuring that heavy condensation will not occur. I will now talk about the manufacturing process of polycarbonate cover. Polycarbonate is classified as a thermoplastic polymers. They can undergo plastic extrusion process, which is an operation for transforming a polymer using an extruder from the solid to the easily moldable molten state, then discharging it through an extrusion die in a predetermined cross-sectional shape and re-solidifying by cooling. Here is our decision matrix for choosing material for our structure, with 1 being the lowest ranking and 5 being the highest ranking. We chose galvanized steel for the making for the structure because it has the highest score. I will now talk about the structure for galvanized steel. Steel, when coated with zinc, it can make it corrosion resistant. It is known for its strengths, often used for construction and as building material. It can also resist weather conditions like wind and rain. However, galvanized steel is more expensive compared to other materials. Now I will talk about the manufacturing process of galvanized steel. The pliable steel will be rolled through large rollers to form flat sheets. The sheets of metals are then cut and welded into the desired shape of the beam. Welding of the different beams is also used for the construction of the greenhouse. The steel parts are submerged in molten hot zinc to coat it and prevent corrosion. The strength could be lost as the structure of the material changes due to corrosion. The beams can be cut into the desired lengths using many types of specialized tools such as the circular saw.
For the shelf, it is made of aluminium. The pros is that it is classified as light metals and it possesses low density. It has high strength, which is good as it can sustain heavy load, and it is corrosion resistant because it naturally forms a protective layer of aluminium oxide on the surface, and it is cheap compared to other metals like copper, stainless steel, and brass. The cons to aluminium is that it's not environmentally friendly since it requires mining to obtain this material. This can be solved since aluminium is classified as a recyclable metal. We can use recycled aluminium for making of our shelf frame. Our rotary device is made of iron alloy. Hard and strong, is resistant to deformation, has excellent machinability and high vibration dampening. The cons are that it has low workability and it is heavy. The manufacturing process for aluminium shelf frame. Aluminium undergoes extrusion. Extrusion is defined as the process of shaping material by preheating a steel billet and pushing it through a shape opening in a die. The extruded material emerges as an elongated piece with the same profile as the die opening. It is then cooled by quenching. The shelf is then made of extruded aluminium and assembled by means of concealed joining system, giving the structural stability and load resistance. The manufacturing process of iron alloy. Iron alloy is a mixture of iron ore, chromium, silicon, nickel, carbon, and manganese. Iron alloys are made primarily in a two-step process. In a primary steel making step, liquid iron is converted into steel by the basic oxygen furnace process, or by melting scrap steel or direct reduced iron in an electric arc furnace. Secondary steel making is a refining process in which alloying metals are added and impurities are removed. Next, we have bioplastic container. Bioplastic simply refers to plastic made from plants or other biological material instead of petroleum. It's also often called bio-based plastic. It's not biodegradable plastics, which are still petroleum-based plastics that are combined with an additive that helps them break down quickly. The strength of bioplastic is that it is more environmentally friendly compared to traditional plastics and is made from renewable materials like cornstarch. It's sustainable and eco-friendly, as 80% of the world's oil is normally used to make traditional plastic, and by using bioplastic, we reduce the use of finite resources. It's also as durable as other types of plastics. The limitations to bioplastic is that plastics may divert land away from growing food and use food resources when we are already living in a food-scarce world. To solve this limitation, however, we can use food waste generated by the greenhouse vertical farm to make bioplastics, so we don't waste any produce that can be sold and at the same time avoid using food resources. The manufacturing process of bioplastic. Bioplastic is typically made from sugars in cornstarch. It is biodegradable, carbon neutral, and edible. To transform corn into plastic, they are immersed in sulfur dioxide and hot water, where it is broken down into starch, protein, and fiber. The kernels are then browned, and the corn oil is separated from the starch. The starch is comprised of long chains of carbon molecules, and citric acids are mixed in to form a long-chain polymer, or otherwise known as a large molecule consisting of repeating smaller units that are the building blocks of plastic.
The plastic needs to be molded into a container suitable for the crops to be growing in. I'll now pass the time to Yew Chong to tell you more about the manufacturing processes.
For the shelf, we have chosen redwood, as it is the lightest and most durable wood for building. And it is also strong to hold the plants and soils, and it's also lightweight so that it does not add much to the overall load of the shelf system. It can be coated with oil or varnish to protect it from moisture. This is the manufacturing process of redwood. Redwood logs turn into redwood planks through nailing, the process of making a piece of lumber flat and square. Holes are drilled into the planks to create an escape for water from the plants. Drilling of screws is also needed to combine the sides of the shelf together. The wood requires an oil finish such as tung oil to stop moisture from damaging the wood. Tung oil needs at least 5 coats. It's non-toxic and it improves on the wood's durability and water resistance. This is our product research for our project. Our project is basically the combination of two already existing ideas, vertical farms and greenhouse farms. An existing solution available in the market that we can integrate to our project would be a thermostat. We need a thermostat because we want to regulate the temperature in the farm, which will allow us to grow more variety of crops, which can't be done by traditional farming due to Singapore's tropical climate. Ideally, we will choose a thermostat that changes the temperature automatically by taking seasonal weather into consideration. The thermostat should also have a humidistat function to control the humidity inside the farm. This is important so that the condensation will not occur in the farm, which will build up moisture, causing algae to grow. My group decided to search for a climate controller each, and then we will come up together and decide which to use. This is our decision matrix for choosing the thermostat, where we decide which of our personally chosen thermostat. We compare them by discussing the cost, reliability of the product, and how well the thermostat controls the climate. We then decided that Valve's chosen thermostat would be the most suitable for our project. Valve's chosen thermostat is the plug-in digital temperature and humidity controller. Both a heating and cooling thermostat. It works as a humidistat or a dehumidistat as well. Easy to use, simply plug the device where you want to control and select the temperature and humidity level best suited for the crops we are growing. Its cost is at $79.95. How it functions is, in heating mode, it can control electric heaters, heating mats, and cables. In cooling mode, it can automate fans, coolers, and mist cooling systems. In humidify mode, it can be used to turn on a device like a solenoid valve, which powers a misting system when the humidity level drops below the level you select. In the humidify mode, the controller can turn on a circulation fan, exhaust fan, or dehumidifier when the humidity level rises above the selected level. This is the detailed drawing for our project. Our finalized material selection includes polycarbonate cover, galvanized steel framework, aluminium shelf frame, redwood shelf, bioplastic crop container, and an iron alloy rotary device. The left picture shows a drawing of our shelf frame, which is 3 meters in height and 4.3 meters in length. The right picture shows the rotary device, aka the gear and chain, where it is 2 meters in height and the top gear is 0.32 meters in diameter and the bottom gear is 0.4 meters in diameter. This is the redwood shelf drawing, where it is 3.9 meters in length, 0.32 meters in width, and 0.25 meters in height. This is our overview of our greenhouse vertical farm drawing with our bill of materials at the top right hand corner. How effective is our solution at solving the driving question? Our farms can and will build on rooftops or shopping malls and car parks, which are all in close proximity to consumers, so produce can maintain freshness because it is near supermarkets. Our farms are compact simply because it is installed on rooftops. There isn't a need to take up agriculture or land space like traditional farms do. Our crops are priced around the same as regular produce harvested in Singapore, except that ours are more nutritious, tastier, and fresher. Our crops are also cheaper compared to imported produce because there isn't a need to pay transportation and taxes for customs. Thank you for listening to our presentation.